numerical roots. So remember, in the last unit, we talked about how to simplify square roots, such as the one shown in this example. We took the square root of 40 and we rewrote it as the square root of 4 times the square root of 10. Remember, then we can take the square root of 4, which is 2, and rewrite this as 2 times the square root of 10. The reason we're allowed to do this is because of the product property of square roots. We can rewrite the square root of a product as the product of two square roots. So for example, the square root of 40, we can rewrite it as the square root of 4 times the square root of 10, because 4 times 10 is equal to 40. So now you can go ahead and pause the video and see if you remember how to do simplifying with these square roots. So remember, when we write it as a product, we want to make sure one of the terms in our product is a perfect square. That's what's going to allow us to simplify. If you need a quick refresher of perfect squares, remember to use the chart that's linked in the lesson resource folder. So the square root of 50 we can rewrite as the square root of 25 times the square root of 2. The square root of 25 is 5, so this now becomes 5 times the square root of 2. What about the square root of 147? We can rewrite this as the square root of 49 times the square root of 3. This now becomes 7 times the square root of 3. What about 5 times the square root of 320? We have a coefficient in front, but the process is going to be the same. We just have to carry the coefficient with us as we go through this problem. So I'm just going to rewrite the square root of 320 just like I did on problems 1 and 2. I'm going to rewrite this as the square root of 64 times the square root of 5. But I'm just going to remember to keep that coefficient of 5 in front. The square root of 64, that's 8, so we have 5 times 8 times the square root of 5, which now becomes 40 times the square root of 5. So let's just, before we get into the nth root part, think about what is a root. So it's helpful sometimes to think about a root as the opposite of an exponent. So for example, when we find the square root of 16, what are we finding? We know the square root of 16 equals 4, but what does that mean? What that means is 4 times itself 2 times, okay, or in other words, 4 squared is equal to 16. Okay, so I want you to start thinking about the root as the opposite of an exponent, right? This is another way of saying what number times itself 2 times is equal to 16. So we can do this with higher order roots also, right? So what if we're trying to find the third root of 64? What is that asking? Well, it's saying that some number, okay, raised to the third power is equal to 64, and we're trying to figure out that number. Or in other words, we're saying some number times itself 3 times is equal to 64. And the cube root of 64 is 4. So that's basically what we're finding out. We're saying 4 cubed is equal to 64, or in other words, 4 times 4 times 4 is equal to 64. So I want you to keep this idea in mind as we work through the next examples. So we're going to get into nth roots, okay? We're going to talk about how to simplify nth roots. So what is an nth root? Well, we talked about square roots so far, but you can actually have any index for your root, okay? So you can have 3, 4, 5, any number. And you have your radical symbol, right? And then you'll have a value under the radical symbol, which is called the radicand. If we have an index of 3, it has a special name. It's called the cube root. Any index higher than that, we name it after the value of the index. So you can have fourth roots, and then if you want to generalize, you can say for any number n, I'm going to call this the nth root. So interestingly enough, we have a product property for nth roots, just like we have a product property for square roots. This is going to allow us to simplify because we can separate a product. Like the fourth root of 24, we can rewrite it as the fourth root of 4 times the fourth root of 6. So what's our strategy to go about simplifying? Okay, the product property can be used to simplify nth roots of numbers, but what you're going to do is you're going to use the roots chart that I have linked in the lesson resource folder. In the roots chart, you can find the table that corresponds to the index, which is the value of n. Okay, so for example, if I'm doing the fourth root of 48, I'm going to go to that chart and find the table where it says n equals 4, because that's my index. You're going to find the highest value in this table that will evenly divide 48. So in this case, that's going to be 16. I'm going to write this 48 as a product. So I have the fourth root of 16 times the fourth root of 3. This table right here tells me that the fourth root of 16 is equal to 2. So I'm going to simplify this fourth root of 16 as 2. So I have 2 times the fourth root of 3. Okay, so this is how we're going to go about simplifying these nth roots. So like I said, this chart is in your lesson resource folder, so use it, please, to help you out as you work through these problems. All right, so let's simplify the fourth root of 243. Okay, so to do this, I'm going to go to that chart and I'm going to find the table where n equals 4. The biggest value that evenly divides 243 is 81. So I'm going to rewrite this as the fourth root of 81 times the fourth root of 3. The fourth root of 81 is 3, so this is now going to simplify to 3 times the fourth root of 3. Now you can go ahead and pause the video and try working on this example on your own. So the cube root of 54, okay, I'm going to go to my chart and find n equals 3. The biggest value that evenly divides 54 is 27. So I'm going to rewrite this as the cube root of 27 times the cube root of 2. The cube root of 27 is 3, so we can rewrite this as 3 times the cube root of 2. Just like with square roots, we can have terms that have coefficients in front. What if we're simplifying 3 times the 5th root of 160? When I'm simplifying, I'm going to focus in on the radical, and then I'm going to go to the n equals 5, and then n equals 5 tells me that the biggest value that evenly divides 160 is 32. So I'm going to rewrite this as 3 times the 5th root of 32 times the 5th root of 5. The 5th root of 32 is 2, so this now becomes 3 times 2 times the 5th root of 5. 3 times 2 is 6, so I can combine those, and I have 6 times the 5th root of 5. Now you can go ahead and pause the video and try doing this example on your own. So we have 2 times the 4th root of 324, so we go to the n equals 4 table. The 4th root of 324, well, we can simplify that by rewriting as the 4th root of 81 times the 4th root of 4. Right, because 81 is the biggest value that evenly divides 324. So the 4th root of 81 is 3, so we have 2 times 3 times the 4th root of 4. 2 times 3 is 6, so we have 6 times the 4th root of 4. So I also want you to realize that when we're working with nth roots, we have some different situations depending on what we have inside the radical, right? What are we taking the root of? So there's different situations depending on whether your index is even or if your index is odd. So if you have an even index, such as the 4th root, if you're taking the root of a positive value, okay, so you see you have positive 81 on the inside here, you can have two real roots. You can have a positive one or a negative one, okay? And remember, the way to think about this is to think backwards. 3 to the 4th is equal to 81, but negative 3 to the 4th is also equal to 81. That's why we have two real roots. If you have a negative value and you're trying to take an even index root of it, you'll actually have no solution. Okay, why is that? Well, why is this 4th root of negative 61 no solution? Why is it not negative 2? Well, if I multiply negative 2 by itself 4 times, think about what happens. The two negatives will make positive 4, right? And these two negatives will make positive 4. So I end up with 4 times 4, which is 16. And if you think about it, it's actually impossible to multiply a number by itself an even number of times and actually get a negative value. So that's why the 4th root of negative 16 will have no solution. 0 is one of those numbers that you multiply by itself any number of times and you just get 0. So it doesn't matter if you have an even index or an odd index. Any root of 0 is just going to be 0. So now let's go to the odd index. Okay, so if we have an odd index such as the cube root, if you have the cube root of a positive number, you have one positive real root. Okay, because 2 times 2 times 2, 2 to the 3rd is equal to 8. If we have a negative, this is different than when we have an even index. Because if you multiply a negative number by itself an odd number of times, you can actually end up with a negative value. So you'll have one negative real root if you're taking an odd index of a negative number. So negative 4 times negative 4 times negative 4, you can see that negative 4 times negative 4 becomes positive 16. 16 times negative 4 is equal to negative 64. So you have one negative real root. So it's an important distinction to keep in mind when you're looking at this and you're trying to take an even or an odd index root of a negative number. Okay, so just to remind you, there's also charts of negative roots and negative radicands, okay? So make sure you use these. These are also linked in the lesson resource folder for you to use as you work through these problems. Okay, so just think about this based on what we just talked about. Which one has a real solution and which one does not? Explain why or why not. Remember, the key here is the index, right? Index 5, index 4. This is odd, so it's going to have a solution. 4 is even, so this one is actually going to have no solution. There's no number that you can multiply by itself 4 times and get negative 64. 5, the 5th root, we can actually simplify, right? Because 5 is odd. So we can even use that chart to help us out. You can see the 5th root of negative 160. If I go to this chart right here where n equals 5, you can see the 5th root of negative 32 is equal to negative 2. I can even rewrite this 5th root of negative 160 as the 5th root of negative 32 times the 5th root of 5. The 5th root of negative 32 is equal to negative 2, so this now becomes 2 times the 5th root of 5. So you can see it's possible for me even to simplify this root.